Hello everyone and welcome to our educational session. My name is Paul Arsov and I'm the founder of the Decentralized Web project. I'm going to talk about our project and several other projects that we did release and we are also working on in the end of this presentation, but the topic today is are the AI models actually intelligent? Several years ago, OpenAI released ChatGPT, taking the world by storm. ChatGPT encompassed a completely new way to interact with computers in a less rigid and more natural language way than we have gotten used to. Most importantly, it seemed that ChatGPT could do almost anything. It could beat most humans on the SAT exam or access the bar exam as well. Within months, it was found that it can play chess well and nearly pass the radiology exam. And some have claimed that it developed a theory of mind. These impressive abilities prompted many to declare that artificial general intelligence with cognitive abilities on par or exceeding humans is around the corner. Yet others remain skeptical of the emerging technology, pointing out that simple memorization and pattern matching should not be considered with or confused with true intelligence. But how can we truly tell the difference? In the beginning of 2023, when these claims were made, there were relatively few scientific studies probing the question of intelligence in large language models. However, 2023 had seen several very clever scientific experiments aiming to differentiate between memorization from a corpus and the application of genuine intelligence. This presentation will explore some of the most revealing studies in the field, making the scientific case for the skeptics. It is meant to be accessible to everyone with no background required. In the end of this presentation, you should have a pretty solid understanding of the skeptic's point of view and skeptic's case. In the beginning section, we will explain a few basic concepts required to understand large language models, the technology behind GPT, without going into technical details. If you are somewhat familiar with supervised learning and the operation of large language models, you can actually skip this part of this presentation. Large language models are a classic example of a paradigm in machine learning called supervised learning. To use supervised learning, we must have a data set consisting of inputs and desired outputs, which are fed to an algorithm. There are many possible models to choose from, which tries to find the relationships between those inputs and outputs. For example, I may have real estate data, an Excel sheet with the number of rooms, size and locations of houses, which is the input, as well as the price at which they sold. These are the outputs. This data is fed to an algorithm that extracts the relationships between the inputs and the outputs. It will find the increase in the size of the house or the location influences, which influences the price. Feeding this data to an algorithm to learn the input-output relationships is called training. After the training is done, we can use the model to make predictions on houses for which we do not have the price. The model will use the learned correlations from the training phase to output estimated prices. The level of accuracy of the estimates depends on many factors, most notably the data used in training. This supervised learning paradigm is extremely flexible to almost any scenario where we have lots of data. Models can learn to recognize objects in an image given a set of images and the correct label for each. For example, a cat, a dog, or any type of other thing we consider or search to find. Classify an email as a spam given a data set of emails that are already marked as a spam or not spam, and predict the next word in a sequence. Large language models fall into the last category. They are fed huge autonomous amounts of text, mostly found on the internet, where each chunk of text is broken into the first n words as inputs and plus one word as a desired output. Once their training is done, we can use them to autocomplete sentences. In addition to many of texts from the internet, OpenAI used well-crafted conversational texts in its training. Training the model with this question-answer text is crucial to make it respond to an assistant. How exactly the prediction works depends on the specific algorithm used. Large language models use an architecture known as a transformer, whose details are not important for this presentation. What is important is that large language models have two phases, training and prediction. They're either given texts from which they extract correlations between words and predict the next words, or given a text to complete. Do note that the entire supervised learning paradigm assumes that the data given during training is similar to the data used for prediction. If you use it to predict data from a completely new origin, for example, real estate data from another country, the accuracy of the prediction would be suffering. So now we are coming back to the question of intelligence. So did ChatGPT, by training to autocomplete sentences, develop intelligence? To answer this question, we must define intelligence. Here is one way to define it. For example, if you have a simple text giving scrambled words which substitute letters for numbers and numbers for letters. Um, then you have a sentence composed by these words, one sentence composed by Stephen Hawking. Um, if you, as a human, analyze this sentence written by Stephen Hawking, then you are going to very quickly figure out that um, in the words which Stephen Hawking typed, for example, the number one, you can substitute for a letter I, and number seven, for example, you can substitute for the letter T, and number three, you can substitute to letter E. And then when you look at a sentence typed with a combination of numbers and letters, you can quickly figure out that word which is 1N73LL1 G3NC3 is translating to intelligence. But this is your human intelligence helping you to understand what this letter means. So it certainly appears as if ChatGPT developed intelligence like our own human intelligence, as it was flexible enough to adapt to the new spelling, or did it adapt? You, the reader, may have been able to adapt to the spelling that you haven't seen before, but ChatGPT was trained on huge amounts of data from the internet, and this very example can be found on many websites. When GPT explained this phrase, it simply used similar words to those found in its training, and that does not demonstrate flexibility. Would it have been able to exhibit this translation from letters and numbers to intelligence if the phrase did not appear in the training data? So this is the crux of the LLM AGI debate. Has ChatGPT and large language models in general developed true flexible intelligence, or is it only repeating variations on texts that it has seen actually before? How can we separate the two? Let's turn to science to explain large language models' abilities and limitations. Suppose I tell you that a person called Olaf Scholz was the ninth Chancellor of Germany. Then can you tell me who the ninth Chancellor of Germany was? This might seem trivial to you, but is far from obvious to a large language model. In this brilliantly straightforward paper, researchers queried ChatGPT for names of parents of 1,000 celebrities. For example, who is Tom Cruise's mother? To which ChatGPT was able to answer correctly 79% of the time. For example, Mary Lee Pfeiffer is the mother of Tom Cruise. The researchers then used the question the ChatGPT answered correctly to phrase the opposite question. Who is Merrily Pfeiffer's son? While this same knowledge is required to answer um, both, GPT was successfully in answering only 33% of these queries. And why is that? Recall that GPT has no memory or database. All it can do is predict a word in a context. Since Mary Pfeiffer is mentioned in articles as Tom Cruise's mother, more often that he is mentioned as her son, GPT can recall one direction and not the other. To hammer this point, the researchers created a dataset of fabricated facts of the structure, like for example, description is name. For example, the first person to walk on the moon is the first person to walk on Mars is Tyler Oakridge. Large language models then trained on these data sets and queried them about the description. Then they were queried who is the first person to walk on the Mars, and where ChatGPT succeeded with 96% of accuracy. But when asked about the name, who is Taylor Oakridge, GPT scored 0%. So this is a very important thing to notice. It is zero, actually zero. This may seem surprising at first, but is consistent with what we know about supervised learning. GPT cannot encode these facts in memory and recall them later. It can only predict a word given a sequence of words. Since in all the texts it read the name followed by the description and not the opposite, it never learned to predict facts about the name. Evidently, memory that is developed only through autocomplete training is very limited. Like this paper is the most important paper that we will explore, aiming at the heart of the difference between memorization and intelligence. It is composed of several mini experiments, all utilizing counterfactual tasks. Here is an example of a counterfactual task. Arithmetic is normally done in base 10, like using the number from 0 to 9. However, all other number systems can be used. Like for example, digital computers use either binary system composing with only two digits, 0 and 1, or they're using hexadecimal system composed with numbers from 0 to 15. And a counterfactual task could be solving arithmetic questions in any base other than 10. The abstract skills needed to complete the tasks are identical, but you will find significantly more examples of decimal systems on the internet and on large language model training sets. When GPT-4 was asked simple arithmetic questions For example, 25 plus 36 in base 10, it answered correctly 100% of the questions. However, when told to use base 9 in its calculations, its success dropped to 23%. This shows that it failed to learn abstract arithmetic skills and is bound to examples similar to what it has only seen. Um, Here's another counterfactual. Python uses zero-based numbering. However, this is only a convention, and we can easily create a programming language that is like one base. Writing code in one base Python variant required the same skills as normal Python, and any seasoned programmer could be able to adapt to the change quickly. Not so for GPT-4. It scored 82% on code generations for Python, but only 40% when told to use one based variant. When tested on code interpretation, predicting that a piece of code would do, um, it scored 74% for normal Python and 25% for the uncommon variant. But we don't have to venture to different Python versions. Even in normal Python, large language models fail when given strange coding tasks that you cannot find on the web. Um, as many researchers and programmers actually found out. In chess, GPT was asked to evaluate together a sequence of moves, um, which whether this was legal or not. In normal chess game, it accurately predicted the legality of a move 88% of the time, but when the starting position of the bishops and knights were swapped, its guesses on the legality of the moves became completely random. While even a novice human player should be able to adapt to these changes easily, um, in fact, some researchers observed that you don't need to change the starting positions. If you start playing a chess game with GPT and make very unconventional but legal moves, it may claim that they were illegal because it has never seen such moves. As one researcher beautifully remarked, when sufficiently advanced, pure pattern recognition can mimic rule-based deductive reasoning, but they're distinct. Playing chess with GPT-4 is to enter Potemkin village, sneak away from the main street into an alley, do something unexpected, and you immediately realize that the impressive looking houses are all propped set pieces. To find the increasingly damning for LLMs as a general intelligence technology. Problem solving often involves coming up with new rules or conceptualizations of a problem. A programmer may write a library that has an innovative internal logic. A mathematician may invent a new branch of math, or an artist may come up with new artistic styles. They all understand the limitations of current paradigm and then create rules for a new one. Even more mundane activities require this flexibility. If the road is blocked, you may step off the marked path. Could GPT-4 accomplish any of this, or any GPT, successful GPT? If it cannot consistently follow counterfactual rules when explicitly told to do so, could it realize on its own that a solution for a problem requires a new set of rules, a break from the default paradigm? Could an engine based on detecting correlations in data be flexible enough to respond to novel situations? Theory of mind is the capacity to understand other people, um, that other people may have different beliefs and wishes than one's own, an ability that is absent in the first few years of child development. One method to test theory of mind is by presenting a child with a box labeled chocolate, which in fact contains pencils. We then show the child the true content of the bag and ask them, what would your friend Jeremy think of the box? If the child hasn't developed a theory of mind yet, they will answer pencils, since they cannot separate their knowledge of the content from which another person may think. The ability is crucial to understand of person motivations and therefore uh, crucial in the development of artificial general intelligence. Imagine that you have a multi-purpose robot and you give it the instruction to clean the room. In the process of cleaning, the robot will have to make several decisions on what to clean or move. Is the crumpled piece of paper important, or should it throw it in the garbage? Should I ask first? In general, an intelligent agent will need to understand my motivation and the limits of my knowledge for it to fill in the implementation details of a complex request. For this reason, when the research claimed the theory of mind may have spontaneously emerged in LLMs, it made a lot of waves in the AI field. This presentation used textual version of the pencil chocolate exam to test GPT release and found that it performed at the level of the 7 years old. This may seem impressive at first, but remember that like this example of the combination of letters and numbers, the training data for GPT may well contain examples of these test questions. It is therefore not a fair comparison to a child who passes the test without any training on similar questions. If we would like to test GPT on a test of mind ability, we must create a new exam, which we can be sure wasn't in the training data. Like some in one paper presents a new benchmark for the test of mind, which includes several multi-participant conversations. During this conversation, some of the participants leave the room for some time while the other participants continue their conversation. The large language model is then asked several questions regarding who knows what. Does, for example, a person called Kaylee know the breed of Linda's dog? Um, who knows that what breed is? What breed would David think it is? The large language model is considered to have answered correctly only if the answer was correct on all questions pertaining to the same piece of information. This can be confusing tasks, but even humans scored 87% on this test. However, GPT release scored either 4% or 12%, depending on the GPT version, hardly consistent with the claim that GPT developed human-level test of theory of mind. It is important to make a more general point about all psychometric tests. People often confuse the test with the quality it is trying to measure. The reason we care about SAT scores is because they are correlated with performance in college, success in theory of mind, exams in children is correlated with other behaviors of value, understanding of person, facial expressions, remembering attributes of a person personality, or being able to watch a movie and understand the motivations of the characters. While these correlations between the tests and the behaviors have been shown in humans, there is no reason to assume that they apply to large language models too. In fact, despite the impressive results on the SAT, GPT versions scored on average 28% on open-ended college level exams in math, chemistry, and physics. Until shown otherwise, passing a test proves nothing other than the ability of memorizations to answer the test questions correctly. But for the theory of mind, there is no correlations to speak of. Whether large language models pass the theory of mind test or not, then they cannot see facial expressions, watch movies, or even remember a person and their motivations from one interactions to the next. Since the behaviors that we're truly interested in when measuring theory of mind are not available to large language models, the idea that large language models developed theory of mind is not only false, but it may also be meaningless. At least requires a few definitions to understand in one of them. One experiment tried to probe large language model planning abilities. One example task presented to the large language model is to stack colored blocks in a particular order given an initial state of the blocks arranged in some orders on the table. The large language model presented with a list of clearly defined possible actions. The large language model task is to specify a list of actions that need to be taken to achieve the goal. A similar task involved sending a package from one address to another when the available actions were track and plane delivery. Those are relatively simple planning tasks using only a handful of possible actions. However, GPT versions scored 12 to 35% for the blocks puzzle and 5 to 14% for the logistic tasks depending on the release and configuration. Additionally, if the names of the actions were replaced with random words from pickup to attack, even if the definition of each action remains similar, GPT's success dropped to 0 to 3%. In other words, GPT did not use abstract thinking to solve these problems, and it depended on the semantics. So what are the conclusions? Defining intelligence is not a simple task, but we would argue that any true intelligence should have at least four different elements. The first one is abstraction, the ability to identify objects as part of a large category or rule. This abstract representation of the world can be referred to as cognitive world model. Like, for example, understanding that different images on your retina refer to the same person, or that a movie in chess is legal as part of a framework of rules that hold for the chess game. The second one is memory, the ability to attach attributes to entities and relationships between entities in the world model, the ability to update them over time. Like, for example, once you recognize a person, you may be able to recall other attributes about them on their relationships with other individuals. Then is the reasoning and inference, the ability to use the world model to draw conclusions on the behavior of entities in a new and imagined world of state. And the final ability is planning, to use reasoning to develop a set of actions to achieve a goal. What the future of artificial general intelligence holds is anyone's guess. Maybe some of the machine learning techniques used in large language models will be used in a future intelligent artificial agent, and maybe they won't. But there's a little doubt that major pieces of the puzzle are still missing before the flexibility required for intelligence can emerge in machines. And with this, I'm ending this presentation, and I'm coming back to the beginning of this presentation when I told you that my name is Paul Arsov, and I'm the founder of the Decentralized Web project and several other projects. But first, the Decentralized Web project is building decentralized communication and advertising platform. The meaning of decentralization is different than the meaning put in blockchain technology, and what our implementation of decentralization is doing is it achieves direct communication from user to user without going through a third party, namely a server or a central point which collects information and then it distributes this information back to users. Once again, we do decentralization by the way of direct communication from user to user. The website and the URL of this project is decentralizedweb.org. Decentralized and web, these are two words, they're typed all together. Then there is dot and it ends with org. Once again, decentralizedweb.org. The second project that I like to mention that we built and released is about a marketplace and collection of non-fungible tokens or NFTs based on three-dimensional objects. From the very beginning of this project, we built our own 3D software engine, and what this 3D software engine does is it reads the file of the 3D object, it opens a window on a computer screen, it loads the 3D object 3D NFT, and then it animates the 3D NFT in a way of moving it in random fashion around the window. But in addition to these initial and basic capabilities, our 3D NFTs can have multiple additional capabilities. The first additional capability of the 3D NFTs is the capability of speaking. The 3D NFTs speak in one of three different voices: male voice, female voice, and whisper kind of voice. The three different voices can then have three different flavors of voices. Like a voice can be spoken in a normal speed fashion, in a fast speed fashion, or in a slow speed fashion. Then the next additional capability of our 3D software engine is the capability of voice recognition. The 3D NFTs can recognize voice commands like, for example, move left, move right, move up, move down, zoom in, zoom out, rotate. The next additional capability of our 3D NFTs is the capability of them having a basic artificial intelligence. You can ask the 3D NFT, who are you? And then the 3D NFT is going to reply with who they are. You can ask the 3D NFT to describe something, and then you're going to get a description of something in few sentences. The next thing I like to mention is that we have our own blockchain instance in which we deploy our 3D non-fungible tokens or NFTs, and we allow our users to buy and receive proceedings from sale in multiple crypto coins. Currently, the choices include Solana Sol, Polygon Matic, Avalanche Avax, and Qcoin, which is a big centralized crypto exchange. They have a coin called KCS. In addition to buying and selling with crypto, we have a second parallel and independent way of buying and receiving proceedings from sale done entirely in fiat currency. You can buy 3D NFTs and pay with your debit or credit card, and then when there is another user, and if you after playing you put this 3D NFT for sale, and then the other user likes in particular your 3D NFTs, and they purchase the 3D NFTs with fiat currency, then you can receive proceedings from the sale of your 3D NFT in your bank account in your national fiat currency. With this said, I'm going to tell you the name and the URL of this website of this project. it is 3dnft.decentralizedweb.org. 3D NFT is typed in a way of the number 3 followed by the letter D followed by three other letters N, F, T, and it is typed all together 3D NFT. Then there is dot, then there are two words, decentralized and web, typed all together. Then there is dot and it ends with org. Once again, 3dnft.decentralizedweb.org. The next project I like to mention is our building charging products for electric vehicles. We estimate that the number of electric vehicles is growing, and at some point it may start exponentially growing up. The current way of charging these electric vehicles is handled in a way of electric vehicles coming to charging stations resembling the internal combustion engines going to gas stations. But we estimate that the number of these charging stations is going to become ultimately insufficient to handle the exponential growing number of electric vehicles. And what we are proposing and building products for is buildings products for deployment and specifically in high-rise buildings. Owners of electric vehicles, they may be living in high-rise residential building, and this high-rise residential building is usually outfitted with a ground floor parking lot or multiple on the ground floors of parking lot. So if like the strata for this apartment building, or the owners of this apartment building decide to purchase and mount products like the one we're building, then the owners of electric vehicle can come in the evening and connect a charging cable to their electric vehicle in the parking lot, in the parking stall that they have been assigned, and leave their vehicle to charge during the evening, during the night and early morning while they are at home. But many owners of electric vehicles, they may be working also in a high-rise office buildings, and then these owners of electric vehicle, when they come in the morning to this office building, if this office building is outfitted with the kind of products that we're building, then the owner of this electric vehicle can connect charging cable to their electric vehicle, request charging, and they could charge the electric vehicle while they're at work during the morning, afternoon, and early evening. With this said, I like to tell you the name and the URL of the website of this project. It is power.rstack.com. Power is the ordinary word for power, then there is dot, then there is word which I can spell it letter by letter. It is Alpha Romeo Sierra Tom Echo Charlie Hotel. Altogether it is rstack, then there is dot and it ends with com. Once again, power.rstack.com. In the main page you can see that we put the links to 3 different surveys. you can fill these surveys and tell us about your needs. The first survey is about hardware, the second one is about software, and third one is about features of charging products, and it is going to tell us about your needs, and we can outfit existing we can build new products or customize existing products to fill your needs of charging products. With this said, I'm going to next project that we built and we did release, and this project has two artificial intelligence entities, and each one of these artificial intelligence entities outfitted with their gender, their own voice, their own large language model, their own avatar, and you, the user, is putting the prompt of the initial interaction for each one of these artificial intelligence entity, and then you can start the interaction between these two entities and notice how these entities are going back and forth with the interactions with each other. But like I can give an example. For example, you have a female AI entity which is outfitted with a female AI avatar, female voice, and specific large language model, and you put the initial prompt to it to be very seductive. Then you have a male large language model which you outfitted with its own avatar, its own large language model, your own voice, and you put the initial prompt to be very angry. And when you request the start of this interaction, you're going to observe the first female AI entity trying to seduce the second AI entity, and the second AI entity is responding in an angry fashion to the first AI entity, and you then, after observing this interaction for a while, when you stop this interaction, you can save the transcript of this interaction as a text for your own viewing, and you can also save the parameters of this interaction and share it with other users on our website, so that they could start and observe this interaction, and observe not exactly the same interaction but similar interaction, because large language models have think against repetition of the same thing. So the other users are going to see something similar but not exactly the same. And with this said, I like to tell you the name and the URL of the website of this project. It is ai2ai.decentralizedweb.org. AI to AI is typed in a way of the letter A followed by the letter I, followed by the number 2, followed by the letter A and letter I. And it is all together AI to AI. Then there is dot, then there are two words, decentralized web, then there is dot, and it ends with org. Once again, AI to AI dot decentralizedweb.org. With this said, I like to tell you about the last project that we're working on, but we did not yet release, and this project is going to make automation agent and and do it in a way similar which OpenAI did put with their Atlas browser. So we're going to automate a sequence of tasks, for example, purchasing specific, looking for and purchasing a specific food from a number of food stores, or searching and purchasing a ticket for a concert or a specific show, or purchasing airplane ticket for a specific day and specific range of day and times, and a specific destination, and a specific number of airlines. And with this, we're going to specify the beginning of the interaction. Then you are going to perform this interaction manually, and in the end of this interaction you're going to define this as the end of this interaction and put a label of this specific interaction, like for example purchasing this kind of food, or like purchasing a ticket for this show, or purchasing an airline ticket for a flight to this destination, to this date. And then next time when you request the specific label, then the automation agent is going to go through these interactions one after another, and perform these interactions until the last interaction, which is probably the to confirm, to have you confirm the payment and make the payment and get the specific food item or the specific ticket for a show or for the flight. And with this said, I'm ending this presentation. Thank you for listening. Thank you for viewing. Have a nice day. Have a nice evening, and goodbye.